It said a particle moving in a straight line with a uniform deceleration has a velocity of 40 meters at a point P, 20 meters per second at a point Q, and comes to rest at a point R, where QR is 50 meters. Calculate the distance PQ and then time taken to cover PQ, and then 3, time taken to cover PR. Now, this is a kind of question on velocity time graph. The best approach to solve this question is first, sketch the velocity time graph. And I'm going to do the sketching. In a velocity time graph, there is a vertical line which is represented as velocity. And velocity is measured in meters per second. So everything on the vertical must be meters per second. And everything that has to do on the horizontal line must be for time. That is why we call it VT graph. That is velocity versus time graph. Now, at this point is origin. So what happened at a point P, I'm going to call this point P. And that P is the same thing as 40 meters per second. So at this point, we have 40 meters. And then the body keeps going down until it gets to this point because it is a retardation. Retardation means it started from a particular velocity and brake was applied, it started going down. Now, at a point given on this question, so P is 40 and 20 meters at the point Q. So let me call this point Q. This is 20 meters per second, even though, and I can call this place point Q, right? Then after covering this time, after covering from here to this point, there must be a time. And that time, which it takes to go from here to this place, we don't know the time. So we don't know the time. Then what happened then from Q to this point, it has come to rest. So I'm going to call that one T2. The T2 is from here to this place, the next time it takes. And that point is given as R. So that means then QR is 50 meters. From here to here is given as 50 meters. So we are going to find it. Now the first question says the distance PQ. Now from P to Q, I don't know the distance. And if you look at it very well, it looks like a trapezium. Or we can say it looks like a triangle and a rectangle. Because the distance of any velocity time graph, it is based on the area under the graph. So area under this graph is a trapezium. Remember, a trapezium looks like this. Yes, that is a trapezium. But here, it's just that it's swapped. If I flip it over, it will look like this. Now, but the first I have to do is I have to take my lead, which is QR. QR from Q to R is given as 50 meters. That means I have to find the area under the curve between P and R, and that is a triangle. I'm going to say half base times height is equal to 50 meters. Half times base is what? Is from here to here, which I don't know. I can just call it T. All right? Or I can just call it T2. Now, T2, now this T2 times the height is from here to here. And since this thing is a rectangle, from here to here is the same thing as from here to here. And that height is 20, is equal to 50. So 0, we cancel this 0, right? Then 2, we cancel 2. Then we say that T2 is equal to 5 seconds. So I have found my time taken to cover PQ as 5 seconds. So from here to this place is 5 seconds. This is 5 seconds. Now that I have found the time taken to cover PR, I'm going to find the distance PQ. To find PQ, I have to note that this is a straight line graph. And acceleration of any straight line graph, velocity time graph, that the slope of any straight line graph is an acceleration. Why did I bring slope in here? Because this is a straight line. And the acceleration of any velocity time graph is the slope of that particular graph. So the slope of this question is acceleration. So I'm going to take the slope from P to Q. And for every straight line graph, the slope is constant. So the slope of PQ is the same thing as the slope of QR. So I'm going to take slope QR, PQ, and equal it to QR. Now, what is slope? Acceleration. Acceleration of PQ is change in this velocity with respect to time. Now, remember, from here to here is T1. So I'm going to say acceleration, which I don't know, is equal to 40 minus 20 all over T1. The first one. And then another slope of PQR is still going to be the same, which I'm going to say another acceleration, though it's supposed to be deceleration, which is a matter of concept. So another one, you can call it deceleration, that's okay. So this one is still going to be, remember, from here to here is the change in velocity. So 20 minus 0 all over, from here to here is the time, T1, right? No, it's not going to be from here to here, it's going to be from here to here, and that is 5 seconds, all right? So this one is A, this one is A, therefore 40 minus 20 is 20 over T1 is equal to 20 minus 0 is 20 over 5. 20 cancels 5, so T1 is equal to 5 seconds. Therefore, from here to here is going to be 5 seconds. All right? So I have found the time now, which is the time taken to cover PR. That is PR is going to be from here to here, which is 10 seconds. So the time taken to cover PR is equal to 10 seconds. And the time taken to cover PQ is 5 seconds. All right? Now let's find the first question, which is distance covered PQ. Distance covered from P to Q. Now, for me to be able to find PQ, I have to consider this shape from here to here to here to here to here, which I called trapezium at the beginning part of this lesson. So what I'm going to do is that, if you look at this one, these are the two parallel sides of a trapezium. This from here to here plus from here to here. Now remember, from here to here is 20. Then from here to here is 40. So the area or the distance of PQ is going to be half plus from here to here is the 20 plus from here to here, which is 40, times height is from here to here, which is 5. So the distance of PQ is going to be half times 60 times 5. This cancel this, we have 30. 30 times 5 is 150. So SPQ is going to be 150 meters. That is the distance taken to cover from PQ. And that is the solution. Please don't forget to like, share, and comment where necessary. Thank you. Also remember to visit some of my website as stated on the video. Thank you.